Hello everyone. Today we are going to discuss about the storage layer in Snowflake. That is the first layer of persisted data. So let me bring my screen. Okay, the storage layer. This is the persisted layer of the Snowflake architecture where it stores the data. So if you see the diagram, the first one, which tells about the database, and the second one which tells like how the data is storing. So it is storing in columnar micro partitions, and where it is storing in cloud storage. So cloud storage can be AWS, Azure, at GCP. So on your right side, if you see, it stores the data in hybrid columnar storage, not like traditional databases. So automatic micro partitioning, built-in semi-structured data support, and optimization. Okay, so this picture tells you about how the data is stored. And when it comes to this explains the micropartitions. Micropartitions, they are contiguous units of storage that hold table data. So there is a range that they provided 50 MB to 500 MB, which is uncompressed and stored compressed data. For many micropartitions per table, you can have many micropartitions per table, and micropartitions are immutable. Services layer stores metadata about every micropartition, like min or max, which is range of values in each column. Suppose if you have 1 to 100, so it stores the min as 1 and max as 100. The moment when you select min of that, then it gives you 1, and max it gives you 100. So it is not going to charge anything for this min and max, a number of distinct values, and it stores the null count as well. So that is what is the that is what it is, micro partitions. So when we go in detail about micro partitions, so Snowflake stores the metadata about all rows stored in a micro partition. So which includes the range of values for each of the column in the micro partition, that is called metadata. It stores. Second one is the number of distinct values. And third one is the additional properties used for both optimization and efficient query processing. If you see, there is a note which provided from Snowflake. Micro partitioning is automatically performed on all Snowflake tables. It's not predefined, so it's automatically performed on all Snowflake tables. Tables are transparently partitioned using the ordering of the data as it is inserted or loaded. So these micro partitions can be used to create zero copy cloning as well without using any credits or for storage. By using existing micro partitions itself, you can create your clone, which is nothing but zero copy clone of the existing database, existing schema, existing table, anything. And when you run, then only it will be charged, not for the storage. So which scenario we can use this zero copy cloning is, suppose when you have something like full load is completed and wanted your team, testing team, SQA, wanted to do the full load metrics. Okay, like what is the total amount, whatever the testing that they can perform on historical load, Probably they can compare with the existing data with this new data which is loaded into Snowflake. So all the metrics they can do on cloned copy. It cannot be updated with the new data which is coming. So that is a point of time data which you can always take as a copy and which you can utilize it for separate, maybe for testers, maybe for other processes, whatever you wanted to take care of that. So usual scenarios are like testers, they wanted to take the metrics or, perform some kind of testing. So they will utilize this until before the incremental happens. So after incremental happens, again, they will compare this data. So for that purpose, zero copy cloning is useful, and zero copy cloning will internally use micropartition. So existing micropartitions it will use. So there will be no charge for storage. That is, we can again touch base when we talks about the feature of zero copy cloning. Next, what are the benefits of micropartitioning? So these are the benefits, like benefits of Snowflake approach to partitioning the table data includes, in contrast to the traditional static partitioning, Snowflake micropartitions are derived automatically. They don't need to be explicitly defined upfront or maintained by users. Second one is, as the name suggests, micropartitions are small in size, 50 to 500 MB before compression, which enables extremely efficient DML and fine-grained pruning for faster queries. Micropartitions, they can overlap in their range of values, which combined with their uniformly small size helps prevent skew. So columns are stored independently within micropartitions, often referred to as columnar storage. This enables efficient scanning of individual columns. Only the columns referenced by a query are scanned. So we can talk with an examples like how micropartitioning are important and helpful for while fetching the data, while doing DML operations. So if you take an example where your downstream applications like Power BI, ClickSense, Oracle BI, whatever you call it, right? So while fetching the data from a huge table, like which stores around terabytes of data, okay? So during the extraction, during the selection of that terabytes of data, the micro partitions will help to prune, which is not which is going to be helpful and which is not going to do entire scan of the table. Okay, entire scan of the table data. Instead, based on the micro partitioned columns, if we use in the where class, so as to get the more efficiency in extraction of the data. Okay, to run the queries faster, optimized queries to get into. So these clustering or micro partitioning, clustering on micro partitioning will help us. So when you fetch, for example, when you fetch select min on min of a column from a table, it gives you so fast because it's already pre-calculated stored in a metadata. And similarly, micro partitioning helps you the min values, max values, or null values, distinct null values, distinct values. So they are going to help us to fetch the data from a micro partitioned columns to avoid the entire table scan, and in a way it will reduce the number of credits. Okay, so I'm talking much about credits and also in the next video, I'll make the virtual warehouse and rest of the stuff. Then we can understand what are the what are the consumption, how the query consumption will be charged in terms of credits. Okay, now moving on to the impacts of micropartitions. So the DML, when it comes to the DML, all DML operations, example, delete, update, merge, take advantage of the underlying micropartitions metadata to facilitate and simplify table maintenance. For example, some operations such as deleting all rows from a table are metadata only operations. Next impact of micro partitions are dropping a column in a table. When a column in a table is dropped, the micro partitions that contain the data for the dropped column are not rewritten when the drop statement is executed. So the data in the dropped column remains in storage. For more information, we will talk much about this in the while altering the table. Next is query pruning. The micro-partition metadata maintained by Snowflake enables precise pruning of columns in micro-partitions at query runtime, including columns containing semi-structured data. So in other words, a query that specified a filter predicate on a range of values that access 10% of the values in the range should ideally only scan 10% of the micro-partitions. That is where the query pruning will help us. For example, assume a large table contains 1 year of historical data with date and hour columns. Assuming uniform distribution of the data, a query targeting a particular hour would ideally scan 1 divided by 8/760th of micropartition in the table. Then only scan the portion of the micropartitions that contain the data for the hour column. Snowflake uses columnar scanning of partitions so that an entire partition is not scanned if a query only filters for one column. In other words, the closer the ratio of scanned micropartitions and columnar data is to the ratio of actual data selected, the more efficient is the pruning performed on the table. So for time series data, this level of pruning enables potentially sub-second response times of queries within ranges as fine-grained as 1 hour or even less. So all predicate expressions can be used to prune. Okay. So this is all about the impact of micropartitions and what is the storage layer, how the storage layer has been loaded the data, okay, how the data is stored in the storage layer, which is in the form of columnar storage, hybrid columnar storage, and they will be stored in micropartitions. And each micropartitions can contain 50 MB to 500 MB, and which is uncompressed, and many micropartitions can be there per table, and micropartitions are immutable. Okay. So service layer stores the metadata about every micropartition. That's what the cloud services layer in the architecture. The first layer is the storage layer. Second layer is the compute layer, which is the which will be used for processing the queries, and the topmost layer, which is called cloud services layer. So services layer or cloud services layer resembles the same, and they will maintain the metadata about each and every micropartition. Okay, so this is all about the storage layer and how the data is stored in Snowflake storage layer, which is the persisted data, and how the micro partitions are going to help us to prune and give us the query in an optimized manner. Okay, thank you all.